Hey Sharon, great to see you. Really looking forward to this. We're going to be doing a two-part series on the history of Cerebon, different binding modes, and then how we're integrating big data and AI to find new molecular glues. Tell me a little bit about the history of Cerebon.
Yeah, happy to. So Cereblon is an E3 ligase that actually has been used in targeted protein degradation for over a decade. And there are multiple molecular glue degraders, or MGDs as we call them, that have been clinically approved that hijack the surface of Cereblon to target disease-causing proteins or targets. This early seminal work suggested that Cereblon recognized target proteins through a very specific binding mode, or degron, called the G-loop degron. Therefore, it was actually thought that there was some limitations to the range of proteins that could potentially be targeted through this approach. In addition to that, some of these early molecular glue degraders had some selectivity challenges in that they weren't just degrading the target protein, but there were multiple off targets as well, and they were actually engaging those.
Wow, that it sounds. It sounds like science fiction, but you've been able to take this and really leverage that. Tell me about how we're doing that at Monte Rosa. How are you leveraging Cerebon?
Yeah, so at Monte Rosa, we've been really steadfast in the goal of rewriting the rules of what Cereblon can do, and importantly, expanding the target space that is really amenable to this approach. What's really important in this is our Queen Discovery Engine, which works at the interface of multiple technologies and disciplines. We use proteomics, structural biology, and various screening platforms to generate data at scale. This data then feeds into our machine learning algorithms, allowing us to engineer, in this instance, highly selective MGDs that degrade a very specific disease-causing protein. Using this powerful integration of approaches, we've actually been able to identify and characterize over 10 novel binding modes. These are binding modes that have never been described in literature before. But I think more importantly, it has given us an access to a wealth of disease-causing targets, including those that are deemed undruggable by more conventional small molecule methods.
That is totally pioneering and very disruptive. So Sharon, what are you seeing as the broader implications, and where is Monte Rosa taking this?
Yeah, so I think this approach has really enormous potential. Wherever there's an unmet need and where a small molecule approach would be a game changer for patient compliance and convenience of treatment, we're really taking our unique understanding of what makes Cereblon reprogrammable. And we're only beginning to show just what can really be done with it. To be honest, we still haven't found its limits. Even so, we're still working to identify other E3 ligases that we think we can teach new tricks like Cereblon. This ultimately will add more tools to our toolbox and expand the space, the target space, even further. And so really there's a lot of potential in this approach that really excites us on a daily basis. Of course, right, this work wouldn't be possible without our partnership with the data sciences team and the integration of AI into every part of our drug discovery process. So I'm really looking forward to you expanding on this in our second installment, John.
Thanks, Sharon. Really looking forward to talking about this.